Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good, and I decided to make a video on physics. I'm gonna be telling you and explaining land breeze, sea breeze. I'm gonna be telling you about thermal and the fact, and I'm gonna be also answering some of your deep questions, which are how birds keep flying for hours and without getting tired and without flapping their wings, and how gliders fly so perfectly without an engine. And yeah, so since I got so much love and support on my previous video, I'm like very blissful and grateful for each comment and like and love that you guys have sent me. So I just wanted to say thank you so much for my teachers for teaching me all of this. Without them I would not be here and I would not be making videos, and like I'm just so grateful to have such amazing teachers. And today this video is inspired by my physics teacher. She is a very nice personality. She's one she's like my favorite teacher. Like she's the best teacher you can like anyone could ask for, and I just wanted to give this video an honor due to my physics teacher. I really love her so much, and she's one of the best teachers in the world. So let's start with our lecture, and again this honor goes to my lovely physics ma'am. Thank you. Okay guys, before we discuss conduction, convection and radiation, I would love to explain to you what is heat transfer. So let's start. So before we should start the heat transfer, you should know that kinetic energy is the energy of any matter in the motion. Like the small particles that make up the matter continuously are moving. They have kinetic energy because we know that anything that moves, flows or does any movement is called kinetic energy. The kinetic energy of particles in matter is called thermal energy. So as you know, they are saying that the kinetic energy of particles in matter, when the kinetic energy of particles are happening in matter, they are called thermal energy. But when thermal energy is transferred, it is known as heat, because the word thermal means heat. Heat is the thermal energy that flows from an object, and heat flows from an object at higher temperature to an object at lower temperature. So you know what is transfer of heat, and now we're going to be discussing some more ways of it, which I'm going to be explaining to you. Okay, so one is thermal equilibrium. So as a picture in which they are showing us there is A moving to B, there is written heat transfer. So I'm going to be explaining you what does it mean. So thermal equilibrium is it is a huge example of it. For example, body A is at a higher temperature than body B. But when the bodies A and B are in contact, A loses thermal energy at a rate higher than the rate at which it absorbs thermal energy from B. So here they are saying that, for example, take a small example that for example like A, you can see this A, as you can see, it has a higher temperature. Like it has a higher temperature. It has a higher temperature than our B, because you can see B has a lower temperature than this. So we can write here LT, lower temperature. So then body B. So when body A and B are in contact, for example, if they are in direct contact, A will lose all of the thermal energy at a higher rate, because then the rate at which is absorbed thermal energy from B, because the thermal energy is absorbed by B from A to B, because this is the process of thermal energy. So we can call it thermal equilibrium. Let's go to the next slide. It's going to be very interesting, so make sure you see it. Okay, so there is also another example of thermal equilibrium. They're telling us that heat always travels or transfers from a region of higher temperature to a region of lower temperature. So here they are telling us that in this in this only process, they are telling us that the heat will always travel from a region of higher temperature to a region with lower temperature. Good, as they are showing us that hot transfer of heat go to the cold transfer of heat. Now we're going to be going to the next slide. Okay. So in the next slide you can see there is another process called thermal equilibrium. If two bodies are in, there are 2 points with it. If two bodies are in thermal equilibrium, if it means that their temperature are not in same. So here you're saying that for example, if we will take two bodies in equilibrium, then that means that their temperature are not going to be same, because you know that in this it will always travel from a higher temperature to a lower temperature, and there it is kind of same. They are saying that their bodies will never be same in this process. Now the second point is that when they are placed in contact, the thermal transfers occurs. They are saying that for example, when they are placed in the contact, like I'm going to be showing you here, they have written that when they are placed in contact, the thermal is going to transfer, the thermal transfers occurs. So let's go to our next slide. I hope you have understand this one. So yeah, let's go with the next one. Heat transfer methods. There are, as you know, it is kind of easy that there are heat transfer methods. There are only 3 heat transfer methods: are conduction, convection, radiation. Today I'm going to be explaining to you convection. In the other videos I'm going to be explaining you about conduction, but right now I'm going to be telling you about only about convection. Okay, so yeah, it's easy to heat transfer methods. Okay, so in this they're telling us that heat transfer methods. Liquids get heated up by convection currents. So here they're telling us that the liquids are going to be getting heated up when the convection currents occur. Like they have also shown us a small figure in which they have shown us this, that the heat conduction of heat in liquids, as they have shown. Though there is a heat transfer methods in solid, they're telling us about all liquid, solid, and method and vacuum methods. So listen clearly and closely. In solid, heat is transferred as vibrations of atoms or molecules in fixed position to spread over entire solid. So here they're telling it is kind of different from liquids, because here they're telling us that in solid the heat is transferred as vibrations of atoms or molecules in fixed position that spread over the entire solid. Now, heat transfer method in vacuum. Heat is transferred by radiation. Example, heat from the sun reaches the earth by radiation. So here they are told something about radiation. Convection. So, for example, if you hold your hand over and under the flame of a match, what do you notice? So you will notice that the hot air expands and becomes less dense and then rises. So we can say that heat is converted upwards. Because if you don't try this, this is very dangerous. But if you notice that if you hold your hand over and under a flame of a match, the first thing you notice is the hot air expands and becomes very less dense, and then it rises up. It starts being rising up. So we can say that heat is convected upwards. Convection. There is also another slide of convection. Convection is so here is the definition. Listen clearly. Convection is the process by which heat is transmitted from one place to another by the movement of heated particles of a gas and liquid. Here they have shown us a great example of convection currents and etc. So here they're telling us that the convection is the only process of there are 3. So I'm going to be reviewing. There are the heat transfer. There are only 3 heat transfer methods: conduction, convection, and radiation. So the function of convection is that convection. The definition is that convection is the process by which heat is transmitted from one place to another by the movement of heated particles of a gas or liquid. So before I move further to explaining the types of convection in liquid and etc., I wanted to tell you that convection is in convection, liquid and gases are poor conductor of heat. However, heat is transferred through fluids called liquids, which are liquids or gases, obviously easily by another method called convection. So here they are telling us that liquid and gases are poor conductors of heat, but however the heat is also transferred through fluids, liquids, or gases easily by another method called convection. So some example of convection is why a balloon inflated with hot air, as shown in the figure 9.6, rises up. Well, a liquid or gas becomes lighter and we can call it less dense as it expands on heating, and the hot liquid or gas rises up above the heated area, and the colder liquid or gas rises up the heated area, and the cooler liquid or gas from the surroundings fills the place in which in turn is heated up. In this way, all the fluid is heated up. Therefore, the transfer of heat through liquid fluids takes place by actual movement of heated molecules from hot to cold parts of the fluid. If you don't understand this, you can rewind the video, and I'm going to explain this one more time if you don't understand. Okay, so now we're going to be learning about convection in liquids. So to demonstrate, there's a figure, there's activity for us, so we are going to be trying to answer it. So let's start. To demonstrate convection in water, drop a few tiny crystals of potassium per nanogram into a flask filled with water and gently heat the flask with a purple streaks of water, and it will rise up forwards and then fan outwards. The water becomes uniformly purplish after some time. The circulation of liquid in this method is called convection current. So you're good thinking why the hot water rises and the cold water sinks, because they have told in this slide that convection is the process by which heat is transferred from one place to another by movement of heated particle of a glass of liquid. So they're saying that the hot water is always going to rise up because it is hot and there is less density in it, and the cold water has more density in it, so it will always sink. So convection in liquids, as you can see, they are the hot water. Convection in gases. This figure is a simple demonstration of convection of gases. The hot air gas from the burning candle goes straight into the chimney above the candle. Cold air is drawn down the other chimney to replace the air leaving the room. So in this process, as you can see, they are showing us that first of all, the hot gases from the burning candle will go up. This is the first process, and then it will go straight up the chimney above the candle, but the cold air is drawn in the other chimney to replace the air leaving the room. So it will replace all of the layer that is going to be going down from it. Convection, a concept in ventilation of a room with fireplace. So there is also another example of it. So the first example, you can see that if when the fireplace like this, its air will go up, and the warm air will keep going up. It will keep going up again and again, and like it will go from these places again and again. But after some time, that when the door is open, the cool air from the door or any window will go up like this, and it will go from this, and it will try to replace the warm air, and the door and the cold air from the window can also come from here, and they will clap like they have shown in the previous one. Okay, so to test yourself, you can like just answer these questions, or you can just try to solve these questions, so it can be easier for you to understand. And yeah. Okay, so now we're going to be I'm going to be telling you about application of convection. This is one of my most favorite parts of application of convection: sea breeze and land breeze. So here we're going to be talking about sea breeze. So during the day, the sun heats the land much faster than the sea. The air above the land is heated and expands and rises. The cold air from the sea moves inland to take its place. Hence, sea breeze is obtained. So here they are telling us that the land breeze is produced because like during the day, mostly like on sunny days, the sun heats up and the land much faster than the sea gets heated up, and the air above the land is heated and it expands. As you know, when the air gets heated from above the land, it will heat up and it will expand and it will rise to the sky. So the cold air from the sea will move to the inland to take its place. Hence, sea breeze is obtained. So the last process they're telling us that the cold air from the sea will start moving with the hot air and it will try to take its place. Hence, then the sea breeze is going to be obtained. Let's go with land breeze. At night, land loses heat faster than the sea because hot air above the sea, which is less dense, expands and rises. Cold air from the land moves towards the sea convection current, and then convection current is formed and land breeze is obtained. As you can see in this process clearly. Application of convection. Electric kettle. It is a good example of the convection because the heating element is always placed at the bottom of the heating current. So the kettle is always put in the bottom of the kettle. Heating element is always placed at the bottom of the kettle, so that the hot water at the bottom, which is less dense, so it can rise up, and the cooler water at the top, which is denser, like it has high dense, will sink into the bottom, like it will sink straight. So then the convection current is set up to heat up the water. As you can see, they're showing us the movement of heated water, of cold water, and then here they're showing us the heat element that at the base that heats up the water. There is another application of convection, which is called fridge or refrigerator. The freezer is always placed at the top of the refrigerator, so that the cold air at the top will sink into the bottom, so that the warmer air at the bottom will rise up to the top. Like this is called convection current, and convection current is set up to cool down the refrigerator, so that the fridge can be cool. So all of the items that you put in your fridge can always keep cool. Okay, so now we're going to be telling you about thermal. Okay, so thermals are the column of rising air caused by unequal heating of the land surface and used by gliders and birds to gain height. So here they're telling us the thermals are the type of column that are of rising air that are caused by unequal heating, like unequal heat and cold mix of the land surface and used by gliders and birds to gain height. Gliding. What causes a glider to remain in air? A glider, such as shown in 9.11, looks like a small aeroplane without an engine. Glider pilots are used upwards movement of hot air currents due to the convection of heat. These rising currents of hot air are called thermals. Gliders ride over these thermals. The upward movement of air currents in the thermals help them to stay in the air for a long period of time. How do thermals help birds to fly for hours without flapping their wings? Well, you might always wonder, how can the birds fly for such hours without flapping their wings? Well, the birds stretch out their wings and circle in these thermals. Like as you can see, the birds always circle like this. Circle through these thermals, and the upward movement of the air helps the bird to climb up with it. They would join and connect. Eagles, hawks, and vultures are expert thermal climbers. After getting a free lift, birds are able to fly for hours without flapping their wings. They glide from one thermal to another, and thus travel through large distances and hardly need to stop flapping their wings. Anyways, that's all about convection. I'm going to be doing a part C of this because I almost explained the first two ones. So I hope you understand what is convection and how it occurs, what are convection currents, what is thermal, and what are the good. So I hope you enjoyed this lecture. I hope you understand what is convection currents and everything. If you did, make sure you give this video a huge like, subscribe to my channel. We are so close. We are halfway to 400. We are at 350 subscribers. We just need 50 more to reach 400. I know we can reach it before this at the end of June. So I hope we can reach it fast. Kindly share this video with everyone you know, with your family and loved ones, so that they would know more about convection currents and convection. Thank you so much for giving me your time. Thank you so much for your attention. Have a blessed day. Remember me in your prayers and du'as.